landfill. And we will then take this and repurpose all the materials and close the circularity loop and put the materials back into the processes. There are only two wastes we won't handle, and that's radioactive and live munitions and explosives. If you want to see some of our projects we're working on, you can go to public.carbotura.com. We're very transparent on everything we do, so you can always take a look at those. So why are we doing this? Well, it's a market-driven solution. We see this 91% going out there of materials, and we believe that when you can get them back into circulation, there's a lot of money and a lot of environmental savings that can happen when we do this. And so we're solving that gap is where we position ourselves. We're not in the waste management business, we're in the circularity business. And we do not compete with waste management companies. We probably disintermediate landfills, but nobody wants a landfill anyway. So our clients are basically in the waste management business. They're either a municipality, they're transfer centers, they could be haulers, they could be recycling facilities. It doesn't really matter. We don't care where it comes out of the trash cloud. We provide what's called a waste elimination contract. And this is the mechanics that we use just to keep everybody accountable. We then take the garbage into a zero fill service center. We produce the materials, and we also capture a bunch of climate credits around that because everything that comes in, we actually process and it comes back out. There is no residual waste out of our processes whatsoever. We monetize all that, and we take all that monetization risk and everything. And then because we're a circular economy, it means that the value of the materials, that's where we make our money, is on selling the raw materials. And we'll rebate up to 100% of our tipping fees, which, depending on where you are on the planet, range from $65 to $100 per ton. And again, that will be rebated up to 100%. So it ends up becoming a zero cost landfill. So how do we do it? We use something called the Regenesis process, and that's where we rematerialize the molecules trapped in waste. We don't need to sort anything. In fact, just give us one bin of garbage and we will then rematerialize the molecules out of them. Now, this really does something really cool. It enables this infinite loop of money and materials in harmony with nature and our lifestyles today. So in our world, it's a little bit different. There are no single-use waste materials. You can have 100% diversion, 100% recycling. We understood right up front that the industry doesn't have a lot of capital to invest. The municipalities primarily don't have a lot of capital to invest into this type of infrastructure that's required. So we went out very early on and organized multiple billions of dollars to be able to deploy our services. And that's what we have about $5 billion in our current funnel right now, and we're adding projects every day. And the other thing, zero emissions, and again, getting back to the rebating approach we take and get it to zero cost. So we love the problems the industry has, the unsorted MSW, the landfill leachates, contaminated recycling, sewage plant sludge, incinerator ash, Those are things that we can recycle back into reusable materials. The cool thing about once you understand circularity is that every single element and molecule out there basically doesn't go away, it just gets changed. And then humans, for some reason, like to discard them and hide them, and we bury them. And it's really sort of crazy. But we're solving that problem. So here's a 100-ton per day system. It's pretty straightforward. We start with what are called multi-phase microwave reactors. And these are just giant microwave ovens. They are sealed. They are ran under a vacuum. There's a nitrogen atmosphere. There's no combustion whatsoever going on here. And we use the frequency of the microwaves to find the resonant frequency of the molecules we want to vaporize. And it does it 2 to 3 times more efficient than any other method out there. and how we do that is by putting close to a megawatt of energy into a reactor. And then we actually separate out up to 16 different discrete material streams. And some of those are actually fuels that we end up using because our systems are completely self-powered. We use the garbage to power it. We actually are a water generator and a materials generator, and we're considered a manufacturing process, not a waste management process. So we take the fuels and we actually use them in a turbine generator. But on the backside of the turbine generator, we have our microwave exhaust system. It's called Zero E, which converts all the exhaust back into its original gases: nitrogen, oxygen, hydrogen, and solid carbon black is what comes out. This has got a negative carbon footprint also. And how we get away doing all these things is that we've combined processes that work in solids, liquids, gases, and in plasma. And we can move molecules back and forth between all these states. And people don't necessarily understand that, but carbon can have a solid state. It can have a gaseous state in CO2, and it can have a plasma state, and it can have a liquid state also. And we work across all those. If you want to look at what our mass flows look like and those types of things, pretty straightforward. Let's take 100 tons a day of trash in. It goes into a multi-phase microwave reactor. These reactors go up to 1200 degrees C, which means that we're also eliminating all PFAS and PFOs and F gases that are in any of the trash. And we're bringing that back to their constituent elements. Now, out of this, we're producing renewable fuels, we're producing carbon, we're producing silica from glass and rubber tires and stuff, and metals. And then a lot of water also, about 20% water. That fuel goes into the gas turbine generator where we basically generate all the electricity. And then the exhaust from that, the flue gases come out and go into a microwave plasma reactor where we basically are taking and disassociating the oxygen atom, deionizing it, and reionizing the gases back out. And that drops out gases where we reuse oxygen, we use nitrogen in our processes, and we also come out with carbon black on the outputs. It's basically looks like toner of a copier. Now, the atmosphere that we're bringing in on 100 ton per day modules, about 40,000 cubic feet of air we're bringing into the gas turbine a minute, and that represents 1 pound of CO2 per minute that we're capturing from the atmosphere. So what we did is we just turned the gas turbine generator into a carbon capture device that captures solid carbon and has a carbon negative footprint now due to what we're doing, because we're capturing all the carbon out of the fuel and out of the air. The PFOs and PFAS, I told you earlier, we reduce them back to their carbon, fluorine, oxygen, and hydrogen levels, eliminating PFAS. What we do basically is molecular debonding. We identify the weak molecular bonds, use the resonant frequency and the temperatures we use, and we then snap those bonds. And that allows us to then vaporize and recondense all the hydrocarbons. Municipal solid waste is made up about 80% hydrocarbons, a bunch of other things, including water and a few other things also. But it's very actually energetic from a molecular perspective. Our process puts out 6 different buckets. These are the buckets, and then we can make some decisions, and we make economic decisions based on the molecules that we want to output according to their values. And so we have all secondary and third level processes where we go in and we do non-thermal plasma, we do thermal plasmas, and we can produce all these different components. We can do cracking, we can also generate carbon, graphite, graphene, those types of things. Our primary focus with our services today are graphite, water, and enough fuel to power the systems. We can do selective depolymerization if it's required, and that's typically used when we would be processing special things like windmill blades or solar panels or something like that. When we look at MSW, these are the fractions we look at in North America. Gives you some idea on the fuels and high heat values and things that we look at, but we also really look at the carbon. So one of the things, it's really confusing to the whole world is waste to energy. Well, waste to energy is probably the worst use of the molecules that are in trash there is. You get $11 worth of electricity out of a ton of trash. You maybe get $80 worth of sustainable aircraft fuel out of a ton of a trash, but you can get $300 to $800 worth of graphite out of a ton of trash, or $1,000 to $2,000 worth of graphene out of a ton of trash. And so we're really focused on carbon-based products as our outputs because they're economically can actually really pave the way for expanding on circularity. The other thing is these oils and gases that we actually can produce in excess of have carbon in them, 87% carbon, which actually is more valuable as a graphite than it is as a fuel or an oil. If you want to understand how trash compares to petroleum and coal products, this is a oxygen carbon and hydrogen carbon ratio map. And it gives you an idea that trash is pretty potent compared to all these other things, actually more valuable in some cases than petroleum and coal. Here's a video of a small reactor. This little reactor can do 4 to 10 tons a day. I don't know if you guys can hear any of the music or not, but we're going to load up this little reactor with just general waste. We've got wood, we've got rubber, glass, textiles, LDPE, paper and cardboard, HDPE, ABS, all these different types of nasty things that are hard to recycle, and foams. We load up the recyclotron, turn it on, and again, no combustion whatsoever. We're doing this in a vacuum with a inert atmosphere. So what happens is it's basically outgassing, and we turn it into this run. We turned into 5 different products. You'll see what comes out here is a carbon. And then we did just two extractions. We did low boiling point and a high boiling point oil. And there are about 600 to 900 molecules in those oils there that can all be separated out. Some of them are very valuable. We also have a distillate and we have a syngas that comes out. 100% of the mass that went in came back out. It just changed phase. And this is zero waste. There are no emissions from this process. And those are all highly valuable hydrocarbons that can be used and reused over and over and over again. Companies that have used or validated or are using these systems today, a lot of them, again, mostly industrial waste streams. Basically, you can get to zero now. You can get zero waste and zero emissions, and you get to 100% diversion. And again, because we're providing all the capital for this, we basically look at a capacity agreement as the approach to do this. We handle all kinds of waste. We have a long list if people are looking for it, but we really don't care what comes in the front end. It's really about what we output on the back end that we're concerned with. We typically will spread and bale MSW so that we stop the emissions immediately as soon as we receive the waste. And that allows us to also store and buffer waste if there's peak periods. Here's some of the systems, different sizes, different configurations. Here's a couple in fabrication, a couple different sizes. Plasma doing exhaust work, about 10,000 cubic feet a minute over on the right side. And here's what some of the graphite looks out from the systems. Right now we're delivering, we've got a contract in the nation state of India, and that contract's about 10,000 tons per day of capacity to be delivered. This shows you a 2,000 ton per day layout. These are not large plants. These are massively parallel systems. These are machine tools, basically, or machines that process 25 tons per day. And we just rack and stack a whole bunch of them up to any capacity, all the way up to about 10,000 tons per day if somebody needs it. This provides extreme redundancy, extreme reliability, and also allows us to run as many different waste streams as we want to with optimized recipes. these are the types of carbon credits we get, renewable energy credits, those things. We've won a couple of awards. We're up for another one this year also. And we support these UN SDGs. The basic diagram of what we do is we take waste in, comes into a shredder, baler, wrapper, we go into a reactor, out comes fuel, water, metal, silica, and carbon, and we take those all back into the market, providing a market-ready solution. And even our generator uses a zero-E technology, which produces graphite or graphenes. And again, we're providing our own energy, and it's a very simple and elegant system. And we also provide remote small communities with shredder balers and wrapping equipment and loading equipment so that we track trash that can come from remote small areas that can use our service centers. And we use a multimodal approach to shipping on flatbed containers. And Rob, that's pretty much everything about Carbatura today. I'll answer any questions.
Thanks so much, Alan. If folks wanted to put some questions in the Q&A, please feel free to do so. Obviously, this is, with graphene and graphite, sort of, I think of it as the new carbon economy, where instead of extracting stocks of carbon and using them and putting them into atmospheric and other sinks, we're taking carbon flows from our material production and repurposing them to higher use. So we have a question about the characterization of the char. And I can tell you that this question is from a highly technically savvy person, so you should not feel constrained to make this a lay response.
Yeah, so the char that comes out is basically carbon that's going to also be entrained with metals, glass, silica, and other elements and minerals that's in the garbage. What we do with that is we go through a couple different phases of separation, stages of separation. We separate out the silica, we separate out the metals, and we end up with a pretty much a char that is, let's call it 90-95% pure. At that point, we go into charcoal activation, where we actually activate all of the char, and we're now breaking it down and activating it. And there are gases that come off of that we actually reuse again. And then we take that activated carbon and we go into a graphitization stage where we actually turn it into graphite. Those processes are about 60, maybe 70% efficient. So we end up with a really high grade, high purity graphite, 99.5, 99.8% pure battery anode level type graphites. And we end up with a 20 to 30% amorphous carbon that we actually just recycle back into the activation system until we turn it into graphite. Now we also can go in through, take that graphite if we want to, or we can take the activated carbon and go into one of our plasma systems and generate graphene if we want to, both turbostatic top down or bottom up, 1 to 5 layer stuff. It really depends what the target output is that we're looking for. But our primary output's graphite from the carbon.
And I'm curious, Alan, in the schematic of the 2,000 ton per day facility that you showed earlier, did that include any of the post-processing elements of your system, or is that purely reactors? And
that was just a reactor. That was just a reactor hall. Mm-hmm. But we have a front end ingest zone where we take in either municipal liquid waste, municipal solid waste, ash, sludge, or tires. That's got a front end where we typically partner with a waste management company because they handle all those logistics. We're not in the trucking business, we're in the manufacturing business. And then on the backside, we have a central plant for power and cooling, and we have a manufacturing plant behind this where all these raw materials go into and get manufactured. When we're doing municipal liquid waste, we're generating a significant amount of water, especially if we're doing raw sewage. And so we also are refining water up to 8 or 9 different classes, all the way up into scientific class 3 DI water, RO water, potable waters. You know, we typically can process all the water back into something that's actually really valuable.
And do you do any dewatering of the municipal solid waste before it goes into the recyclotron, or does that process essentially extract the water, which you then post-process?
Yeah, so it really depends on what the dissolved solid level is, or the moisture content level is of what's coming into us. When we're dealing with something beyond 30% moisture level, um, we will typically roll it through, and depending if it's like raw sewage coming off of septic trucks or coming off of stormwater vac trucks, we'll go through a 3-phase decanting where we're pulling oils, water, and solids out. That water goes right into water refining. The oils go back into our oil processing stuff. We're into a reactor. And then the solids go into a reactor also. Now, the solids come out, typically we'll end up running those into a thin film evaporator that runs at about 450 degrees. And we come out with basically pellets of dried sewage that are now less than 5% moisture. And they're at 400 and some degrees. And then we push that right into a reactor and process it. And those things are vaporized almost instantly.
Great. And what would the footprint be in terms of, land area, acres, whatever, for a fully integrated 2,000 ton per day system?
A good rule of thumb, for every 100 tons per day of capacity, you're going to need around 6,000 to 7,000 square feet.
Okay.
And that'll cover most applications. Now we are changing some reactor designs to go a little more vertical, where we can take 2 bales of garbage, 8,000 pounds a cycle, and that's a 3.5-hour cycle on 8,000 pounds of garbage. And so when we're running multiple reactors like this, it's a continuous batch operation. Each reactor runs about 3.5 to 4 hours to process 8,000 tons. And then at that point, we reload it. But there's other reactors processing at the same time. So it's, from our perspective, it's continuous, other than the reactor itself's a batch.
Right. Well, that you anticipated one of the questions from the audience that I was going to ask you. The other question that came in was what is the cost of a waste elimination contract?
So it is a capacity agreement similar to a power purchase agreement or a network services agreement or a manufacturing capacity agreement. We own, operate, and manage the whole system and process. We charge $75 to $100 per ton to eliminate the waste. If our customer has met the requirements of delivering that waste, they're eligible for an annual rebate of 100%. So it can end up becoming zero cost to them.
Excellent. So we will have time for more Q&A at the end. I'm going to ask Natasha to introduce Sweep and discuss how a technology like the recyclotron might be credited under the current Sweep system.
Sure. Okay. Thanks, Alan. Thank you very much for that peek into how your Regenesis process is helping the industry to capitalize on, a real solution that will provide 100% diversion and 100% circularity. We're really excited to see this develop and what's to come if this actually does take up and become an accelerated implementation into the industry. So let me get my slides up over here. Okay. Y'all got that? Okay. Okay. So cool. Yes, I'm Natasha Dyer, SWEEP's Executive Director and Program Manager, and I'll spend the next 10 minutes or so giving you a background on SWEEP and a broad view into the various categories that SWEEP uses to certify projects in general. And while at it, at the same time, I'll be giving you a glimpse into how an innovative technology like we just witnessed from Waste Regenesis fulfills credits for certification. And so throughout the course of the presentation, you'll see where those credits are, and then you'll also see where we invite you to actually download the standard after this webinar, and you can actually look at different credits and see how, not only how Waste Regenesis, the credits that we pulled out for them, not only how they apply to the standard, but most importantly, to look at any categories and credits you feel like if you want to go through the certification process, like what credits like your operation could go through to actually go through SWEEP certification. So let's hop in. Let's see. Okay. All right. Okay. So at SWEEP, we have a vision of a world without waste, where all of society's discards are viewed as commodities to be continuously cycled back to their highest and best use. Therefore, it is our mission to aid in the transforming of the solid waste industry into one that is rooted in sustainable materials management. And we do this basically by being a rating system that incentivizes and rewards local governments and their solid waste handlers to certify that not only their material streams are circular, but we even look into making sure that they have an operation that's being run sustainably. And so sustainable materials management is actually a phrase that was coined by the EPA in 2009, and a hopeful new way to view this industry, right? An industry that can be an instrumental player in injecting circularity into a system that will then be instrumental in reversing the negative effects a linear model of simply taking, making, and discarding of goods is having on our environment. So just a little bit of background about how we came about. Rob, who's been moderating for us, actually founded SWEEP in 2016. And he's the same gentleman who founded LEED, which some of you may know is the largest and fastest growing and most recognizable green building rating system used around the world in about 170 countries, and actually been active and relevant for the last 25 years. And just as it was when Rob was creating LEED to measure efficiency in building energy and water usage, he saw similar irregularities in the waste industry. There was no universal measurement for diversion or even universal definitions for what was being measured. And so according to the US Census, there are about 89,000 local governments and special districts in the United States. And in those 89,000 districts, you will see 1,000 different types of recycling programs and systems. And that is because there's no standardization. That's why you have 1,000 different systems. In an industry with materials that are being diverted from landfill, there's not a proper definition that is actually able to be transferred to all these different systems. So just take a look at a few waste characterization studies and you'll see plastics being called one thing, or that they're not being called on another study. Same with green waste or organic waste. On one study, it'll be simply categorizing the yard trimmings that a city collects. And then in another city, you'll see that green waste or organic waste will actually be calling out yard waste that's been commingled with wasted food that someone pushes out to their curb for collection. So with no real standards and definitions, currently everyone makes up their own rules and declares victory, showing great levels of diversion using very different criteria from the next city or the next jurisdiction. So at SWEEP, one of the key pillars of our work is setting about to clearly define industry terms, and we are creating a standard and definition so that one day it'll be possible to compare progress across cities based on metrics and systems that everyone is using. Let's see. So to get a snapshot of the ecosystem that SWEEP operates in, similar to the true standard, which is on a micro level, certifies how well a company's buildings or campus of buildings is performing at minimizing what they send to landfill. SWEEP then certifies what's going on the macro level, expanding its view to the ecosystem that is the materials management industry. So once those companies roll their recyclables out to the curb, those true certified companies, what's happening to that stuff? Once it's gotten on that truck, are these valuable resources headed to a MRF for further separation and circularity? Are organics headed to a composting facility? Or is everything instead headed to a landfill where they will lose their next level of worth and value? That's what SWEEP is certifying when an entity goes through our process. that the materials management industry within a local government's web is creating true circular solutions for their discards. Oops. And because of this model of analysis, what we're looking at SWEEP to certify this type of circular and sustainable operation, the only parties eligible to participate in SWEEP certification are local governments and the materials management handlers themselves. The haulers, the MRFs, the transfer stations, the commodities processors like composting facilities, and those that process C and D discards. So even using the technology that we've just witnessed today. So membership with SWEEP is then extended to nonprofits. Like if you can't be a certified entity, there is a membership community that we do love to have within our not even our walls, within our community, because these are people that have actually really helped SWEEP as it comes to like creating the standard that we're looking at to transform the sustainable materials industry. Their use, some of you may be on the call, hundreds of you, some with decades of experience have given SWEEP thousands of hours to create this standard that now goes through to basically determine what an entity is doing to be sustainable. And this is extended to nonprofits, consultants, waste brokers, and even the municipality, at the municipality level or at the processor level, people that can actually go through the certification can also just be members and come on board and help us to keep crafting and defining what being a sustainable waste provider really means. So certification in SWEEP is based on measuring your operation against 5 performance categories. And certifying entities are given a credit for each category based on specific measurable and verifiable actions. I will give you an overview of each category in a bit and how they pertain to innovative technologies, how today's innovative technology also will be, how it also could gain points. And I'll kind of overlay those to show you in general how you can go about being SWEEP certified and then where Carpentura's solution actually falls within getting credits for solutions. But you will see here that everything totals up, so through these 5 categories, everything will total up to about 100 points. And there's even been room baked in for innovation. So if there's basically something novel and clever that you all have come up with that hasn't been called out in the standard as a way to meet ideal diversion from landfill, send that to us and we can bake that in, and then you get extra points for innovation. And in total, this is how it all adds up, just similar to LEED. SWEEP certification comes in levels of certified, silver, gold, and platinum. And then eventually there will be a SWEEP 0, which will be a pass or fail system. And so these are the categories. I'll go over them a little bit more in depth. So just to begin, you'll see here that our innovative tech today actually will fall mostly or only within post-collection recovery and that post-collection disposal categories, with the totals being able to win is about 16 points within those credits and categories. But I'll go through all of them and then eventually tell you how Carpentura would win today. So let's first talk about sustainable materials management and policy. So this is pretty straightforward. This is a policy. This is basically looking into and awarding credit for any person going through the certification process, whether that's the local government through policy or the actual handler through programs and initiatives. Like what mandates have they set for themselves and in their operations to make sure resources skip the landfill and that there are sustainability built into their programs. So again, because I love organics, right? That's are they banning organics from landfills? So as not to create that harmful gas and creating wonderful compost that goes right back into the soil. And another example is in the built environment. Our cities deconstructing their built environment in such a way and then creating laws that mandate that material is skipping the landfill, because we can see that there's so much value. I mean, for so long, when we think of taking a building apart, it's just coming in and demolishing it and rendering it useless and smashing it to smithereens and tatters. But like our city's really thinking that those are windows, that's steel, that's concrete, that's roofing, that's all pieces that can actually go back into markets and sold into creating new buildings and even new jobs. So what kind of mandates and what kind of policies are local governments instituting and placing on themselves to make sure that there's more circularity in materials. Next category is waste generation and prevention. And this category is about measuring and tracking performance and analyzing trends in municipal solid waste generation. So credits to be gained here basically give points for successfully reducing waste generation on the front end. And that could be met with a campaign, a public outreach campaign, like how are you reaching your constituents and letting them know that actually source reduction is much more effective than recycling, right? And so the next category then would be solid waste collection to gain points under sweep. And in this category, you earn points by reducing greenhouse gas emissions generated by how you collect your waste. So that's your trucks, your transportation. Have you considered switching out your fleet for an electrified one or a fleet that's run on compressed natural gas? There are even credits to be gained in this category for staying on top of the safety and training of your workers, since the level of danger facing sanitation workers is still very, very high, only dropping from 5th most dangerous to 7th. And it was really the 3rd most dangerous job just several years ago. And so what have you done to invest in their safety and their training to make sure that everybody's happy and healthy? And so next category is post-collection recovery. And this category focuses on landfill diversion of all recyclable materials. So that's everything skipping the landfill. And of course, what we saw today qualifies. And this could be through all kinds of different recovery methods. So making sure resources are getting back into the market to get the highest and next best use out of them. And so we see here that, let me go to the next slide. These are the particular credits out of this category that the technology that we just saw today would actually win credits or points under. And so we've got material recovery and per capita disposal optimization, producing high quality products from recovered organics. We saw that today captured by really effective biochar, creating biochar. Energy efficient and low emissions operations, that's self-explanatory. There's also material recovery and per capita disposal optimization, which is a credit that aims to broaden the horizons of what materials can be collected and later reintroduced into the market as recycled material. Also serving as a baseline standard for per capita disposal. There's also good neighbor practices, which is very important. This credit aims to minimize impacts on community quality of life for material recovery and organics processing facility operations. So SWEEP is really like a very holistic view of just transforming the waste industry from one to that affects people, planet, and prosperity. We're looking at all three prongs. And then back here, the last category was post-collection disposal. And this category in general measures how effectively you dispose of materials that are truly waste and have no higher value, all that inner kind of dust or ash. It's important to note that there's no points given to disposal, but best management practices are incentivized with these credits. So this is where landfill gas created from organic waste is housed. So if you've got a landfill and methane's already coming off of it because there haven't been no laws that have diverted organics from your landfill quite yet, are you finding ways to capture that methane and turning it into a renewable energy that can then power the buildings on your campus, or finding ways to turn that into a fuel that can power the city's fleets? And so in the case of today's speaker, there are, let's see, a potential of 4 points that could have been gained from their wonderful process. And to delve deeper into those, that's what I was saying, the standards on the bottom there. So if you guys want to actually delve deep into all these credits and see what they're about, see what their intent is, see how to win them or gain them, please download the standard. And also, if you aren't able to jot this down today, we'll be sending out an email probably within sometime next week that actually has this information, and then we'll be uploading the webinar to our website. You can actually just visit the video again and to actually get this information on where to download the standard. Let's see. So these are the tools that we use for going through the certification process. Again, this is the standard. It's a manual that's about 300 pages. I shouldn't have said that. That's probably too much information, but it's step by step. So don't feel overwhelmed. But it's a step-by-step on how to certify, and it gives in-depth case studies on best practices, with purpose and intent behind each sweep performance category and credit being outlined. And that was once again helped to create by wonderful people from the industry, like people like yourselves on the call. And then for reporting, we use the Retrack Connect as our online reporting platform, which many of you may have used to participate in the municipal measurement program. Retrack is a well-known platform for many different municipal solid waste measurement initiatives. And so here's a listing of our dozen or so sweep pilot participants, sweep plus pilot participants, spanning local governments and industry. In fact, if you look at the first 4 on here, and actually one at the bottom, we are in the process of certifying these organizations and entities with one, hopefully, probably within the next month, I would say. And the public standard should be coming out soon, right after. And so stay tuned for a call for a way to participate and weighing in on that next iteration of the standard and how we can actually fine tune it and make it just a little better. And so some benefits of going through the certification process. It's been shown that municipalities that go through the process realize 25% more diversion due to savings from landfill tipping fees. Also because SWEEP is measuring performance against the standard as a third-party verifier. Once you go through the certification process, you are sending a message to your constituents that you're a leader in sustainability, something many more residents are noting and as important to them. And a third party is really the way to go. It's a clear view. It's not you slapping yourself on the back and saying that you're diverting, doing the right things with your discards. It's actually an organization that has no skin in the game and actually just sort of certifying that you are doing as you say. It's a clear view because also because corporate greenwash is becoming more and more pervasive these days. Also, with more young people being concerned with linking themselves to sustainable and climate efficient causes and business models and bottom lines, if you're an employer, you'll be able to attract a younger, educated, and innovative workforce who want to align themselves with corporations who are walking the talk. And so recapping, these are some ways to get involved. If you're a local government and industry provider, we really would love for you to go through the certification process, but if you're not ready to do that just yet, again, we mentioned the SWEEP membership opportunities, and you can just join for like a nominal fee. And then you're able to join our committees that again are our technical committees that are crafting the standard. And sometimes when we have some kind of more technical issue that we can't solve, there's some ad hoc committees that do meet up together to kind of hammer away at that and then create a solution that can then be implemented into the standard. Let's see. And then these are a listing of a pretty good listing of most of our members currently. Let's see some benefits of being a member. Again, there's the technical committees, and then when we roll out our equivalent of our lead GA or the True Advisor Professional accreditation within the next several months to a year, that's a credential that you can put behind your name, and we'll have some discounts, like a 10% discount off that training program if you want to become a SWEEP accredited professional. And then just like today with Carbatura, they're one of our members. We would love to offer you to come back and do a monthly webinar highlighting a project or program or initiative you're proud of that's doing well in your city or town or your business. And we have really great relationships with the waste industry publications. So always do a press release to let the industry know that you've made the right choice and you're moving towards sustainable materials management. So that's it there. And I'd love to thank you for joining us today. If you have any other questions, please reach out to us at info@sweepstandard.org. Visit the website, and again, go to the website to download the standard, to give it a spin, give it a look. And just want to let you know that our next webinar will be August 31st, where we'll be having one of our newest members on too, Center for Eco-Technology, joined right about the same time Carbatura did. And basically, for the last 40 years, their work is focused on the need to tackle climate change and to build a just and equitable transition to a low carbon economy. And so what they'll be focusing on or discussing is how they operate in the Northeast with this mission and highlighting initiatives around helping businesses to divert construction and demolition materials. And they even highlighting their own retail store. They have a retail store called Eco Building Bargains, where this way that they help cities up there to dismantle their buildings properly is funneled right into the store, and I think it's the largest in the region. And so they'll also be talking about how they implement strategies to mitigate food waste and how they're piloting reusable takeout containers at eateries. So that's really interesting.
So lots of
please
good
join us.
ideas for
Yeah.
the waste generation and prevention category.
Yeah.
And just to supplement what Natasha said about opportunities for getting involved, we will be convening a new national consensus committee, which is part of our consensus standard development process. You do not need to be a member of the consensus of SWEEP to participate in the consensus committee. So folks, anybody who joins one of our webinars will be receiving an invitation to join the National Consensus Committee. And essentially what the NCC does is it reviews the standard, makes comments on it, and votes whether to approve it with comments or disapprove with comments. And then the final, if we get a majority of the National Consensus Committee approving the standard, then it becomes public. So the distinction between the NCC and the SWEEP committees is that the SWEEP committees put together the content of the standard and evaluate its boundaries, its implementation, and sort of, very rubber meets the road. And then the National Consensus Committee, which is a broader committee, all people who are members of SWEEP or others who are professionals that are not members have a chance to weigh in on the standard and make a mark that way as well. So keep your eyes peeled for an email inviting you to the National Consensus Committee. Again, there's no fee for that. There's no requirement to be a member of SWEEP, but because you've shown interest in sustainable materials management and have expertise in that area, we would value your input in making this national consensus standard as best as possible. So thanks again for joining us today. I wanted to thank Alan and Tyler for their presentation and answering all of the questions that came up. We look forward to working with you and others to make SWEEP into the leading sustainable materials management standard in North America and eventually the world. If you don't, you pay me $1 million. But thanks again for joining this webinar. As Natasha said, end of August is our next one. Please visit our website for more information about SWEEP. Join us, help us make this the standard, demonstrate the radical confidence that we're going to be able to tackle these environmental problems through frameworks such as LEED, such as SWEEP, and together we'll be able to solve these existential issues and demonstrate that we are worthy of this beautiful planet of ours. So with that, any final words, Alan or Tyler?
No, thank you, Rob.
Thank you, Rob. Thank you,
Okay,
Natasha.
well, thanks so
Thanks for
much.
joining.
We will put today's webinar on YouTube. So sadly, this boomer did not quite start the timer at minute 1, but most of it and most of Alan's presentation will be on. And at some point, we'll hire somebody who is a better tech manager than I to deal with the complicated stuff. So thanks again for your attendance, and we look forward to seeing you all at another SWEEP webinar. Thanks so much.
Thank you.